Everyone, welcome to the demo of our open source library called EtherSQL, which pushes data from an Ethereum node and puts it into a queryable database. In our case, it is the PostgreSQL database. So EtherSQL works using Python 3.6 and above, and we provide several command line options. So the first command line option that you can use is to get the current block number in your connected node. So we see our current block number is almost 5.7 million. And we also connect this using this library, we connect to a PSQL server, PSQL database, where we can, for example, check out what is the current maximum number, block number in our database. So we have almost 50,000 blocks in our current database. And we can see we have pick blocks, logs, receipts, traces, transactions, uncles. These are the type of tables that we have. And what I want to show you right now is how quick EtherSQL is in pushing data from an Ethereum node to this particular database. So what I'll do right now is I'll delete all the tables that we saw. So this has dropped almost all the tables. No tables are remaining anymore. And I'll recreate those tables. I have recreated those tables, and we can see that there are no blocks anymore in the blocks table. And I'll open 10 parallel workers, 10 parallel celery workers, which are connected to my personal parity node. So they are connected to this database, PostgreSQL Ether SQL database, and they're connected to my personal parity node. And I'll start syncing blocks. So I'll start syncing, and I'll tell the last block number that you have to sync is 10,000 blocks, and it will find the first block number, which is the highest block number in the database. So what is happening right now is it first check what is the highest block number, which is 0, and then it started syncing or pushing blocks from the Ethereum node to this database from block 0. And we can see that several workers are working very, very fast. And we started this process at 12:49:35, and let us see what is the current block number in the database. We see that it has pushed almost 7.600 blocks already, very, very quickly. And I think it has pushed almost all 10,000 blocks. So we started our process at 12:49:35, and it pushed all 10,000 blocks by 12:50:06. So almost in 30 seconds, it has pushed all 10,000 blocks into the database, and then you can do queries. You can do simple queries like how many uncles are there in my 10,000 blocks, or you want to see what are the types of data that are available in the blocks table. See, we have blocks, block number, block hash, parent hash, difficulty, all these kind of details. And suppose I want to see how many blocks were mined by a particular miner in these 10,000 blocks. I can write a simple query saying select miner, count the blocks, number of blocks that he has mined from this database. And order by uh, num. This should work. And yes, we see that. I think I should have added this. we see that this miner has created almost 2142 blocks and something like that. So you can do data analysis very quickly by pushing data from an Ethereum node to an SQL engine. And if 10,000 nodes can be pushed in almost 30 seconds, then very, very quickly you can push the whole blockchain in a matter of days into your SQL engine. So that's all for now. And thanks a lot.